Welcome to the Deep Dive. This is the show where we take, well, a whole bunch of sources, articles, notes, maybe some research, and really boil them down for you. We want to get to the core insights, maybe find some surprising facts, give you that aha moment. Basically a shortcut to getting genuinely informed, maybe with a little bit of fun along the way. So today we're jumping into something pretty crucial in the world of a sustainable building. It's all about LEED V5 energy metering and reporting essentials. And look, this isn't just about checking boxes for compliance. We're talking about understanding how buildings can genuinely get smarter, more efficient, truly sustainable. And data is the key. We'll be digging into the details of the new LEED V5 rules. Our main source today is a really interesting blog piece called LEED BD+C V5 Energy Metering and Reporting, EAP4, Powering Smarter Buildings Through Data. It also points to some foundational stuff like the big one, ASHRAE Standard 90.1. So yeah, we're going to pull up the really important bits from all that just for you. Okay, but before we really dive deep, just a quick thing.
If you find this kind of stuff valuable and you want to keep up with, well, everything that's changing in our world, definitely hit that subscribe button. You'll hear more about this world, and we're always tackling new, fascinating topics. You really won't want to miss what's coming up next. All right, let's get into it. We're starting right at the foundation here. This idea that building energy management is, and I quote, the cornerstone of sustainable construction. That's a strong statement, isn't it? The absolute bedrock.
It really is. Cornerstone is the perfect word.
So what exactly is this AED prerequisite we're talking about? Energy and atmosphere prerequisite EAP4 energy metering and reporting.
Yeah.
And it's for LEED BD+C V5. New construction. That's building design and construction, right?
Yeah.
New builds, major renovations.
Exactly. And calling it a cornerstone makes total sense because honestly, if you don't know precisely how a building is using energy and maybe even generating it, then all your other sustainability efforts like water savings or material choices, they're kind of built on shaky ground,
Right.
The main idea behind AP4, it goes way beyond just ticking a box for lay. It's really about giving building owners, the operators, the people on the ground, actionable data.
Actionable data. Okay.
Yeah, not just numbers, but intelligence you can actually use to make smart decisions. The goal is enabling effective energy management through continuous tracking and reporting. Think about it. Instead of guessing based on a monthly bill, you get this near real-time understanding, system by system. It's a huge leap in control. And what's really interesting, I think, is how this changes energy use. It stops being this abstract line item on a bill, something you just pay, and it becomes something measurable, manageable, dynamic. For ages, energy was just this fixed cost that showed up once a month. You didn't really know the why behind the number.
Yeah, just pay the bill and move on.
Exactly. Yeah. But EAP4 pushes for detailed, continuous tracking, and that lets you proactively find these ongoing opportunities for energy savings and greenhouse gas reductions.
So it's not just about cutting costs then?
Well, cutting costs is a big part, but it's more. It means you can pinpoint systems that aren't performing well. Maybe find peak times you could shift usage away from, or even catch small equipment issues before they become big energy drains or expensive failures. And, of course, when you cut energy use, you're directly cutting carbon emissions too. And stepping back even further, this whole data focus, it really fosters transparency and accountability in building energy performance. That transparency is key, not just for the owner, but for tenants who care about their footprint, for investors looking at ESG performance.
ESG, right? Environmental, social governance.
Exactly. And even for the community. When you have clear, verified data that's reported regularly, everyone can see the building's real commitment and how it's actually performing. It drives accountability. No more vague, we're green promises. It's about showing the results.
That really does sound like a major shift. So definitely not just a bureaucratic hurdle for LE. It changes how you build and manage the building for its entire life.
Okay, so for a building owner and operator, what are the tangible benefits? What do they actually get out of this level of detail?
Well, first off, and this is a big one, you're talking about real operational savings through energy efficiency improvements. It's simple, really. When you know exactly where every bit of energy is going, electricity, gas, whatever, you can find the waste and stop it. Maybe it's just tweaking HVAC schedules, or optimizing lighting, or finding that old, inefficient piece of equipment that needs replacing. These data-driven tweaks, they add up to seriously lower utility bills. I mean, we've heard stories where continuous monitoring found energy waste equivalent to powering dozens of homes just by finding hidden leaks traditional audits missed. Yeah, it hits the bottom line. Everyone gets that. And beyond the money, it gives you this enhanced visibility into energy use and emissions performance, something you just couldn't get before. Imagine a dashboard showing your lighting versus your HVAC consumption right now, or how much gas the heating system used overnight.
That level of detail is powerful.
It really is. It lets you pinpoint issues immediately or see what's working well. You understand your building's unique energy signature. And that helps you make smarter decisions about everything, maintenance, upgrades, even negotiating with the utility company. It enables that proactive management.
Absolutely. That visibility is exactly what enables the proactive identification of issues and opportunities for continuous improvement. You're not waiting for a massive bill to tell you something went wrong last month. You can see anomalies almost as they happen.
Like a sudden energy spike overnight when no one's supposed to be there?
Exactly. Could be a faulty sensor, equipment left on, a system glitch. And connecting this to the bigger picture, this constant data stream means you manage the building dynamically, not statically.
Static meaning like an energy audit every few years.
Right. That's just a snapshot. With EAP4, it's like you're running a continuous audit. You're constantly learning, constantly tweaking. It's this feedback loop that drives improvement over the building's whole life. The building itself is telling you its story and data. And finally, there's the leadership aspect. Being transparent with this data, it's a clear demonstration of leadership and commitment to sustainability goals and transparency. In today's market, ESG is huge. Tenants want green spaces. Employees want responsible workplaces.
So the data itself becomes a statement.
Precisely. It's not just saying you're sustainable, it's proving it with hard data. That makes the building more attractive, potentially commands higher rents, increases its long-term value because operating costs are lower, and it has a strong green reputation. The data tells a story of responsibility.
That makes a lot of sense. Data as proof, not just aspiration. Okay, let's get into the mechanics then, the nuts and bolts for project teams. How do they actually do this? Comply with EAP4. You said there are two main criteria. Let's start with the first one, energy monitoring and recording. What does that actually involve putting into the building?
Right. This is the hardware layer, essentially, the infrastructure. Teams have to install new energy monitoring devices, or they can use existing ones if they meet the standard. And the key standard here is ASHRAE's Standard 90.1.
Ah, ASHRAE 90.1. That's the big one for building energy efficiency, right?
It is. It's the gold standard, really. It dictates everything from insulation levels to HVAC efficiency. It basically sets the minimum performance level for energy efficient design in new buildings and major renovations. It's the technical backbone. Now, here's a crucial detail. The specific version of 90.1 matters, and it depends on when the project is registered with LED. So, for projects registered before January 1st, 2028, they need to comply with ASHRAE 90.1 2019 or a newer version if one comes out. But for projects registered on or after January 1st, 2028, the requirement jumps up. They'll need to meet ASHRAE 90.1 2022 or newer.
So the standard keeps getting tougher over time.
Exactly. ASHRAE updates it regularly to reflect new tech, better building science, and, frankly, more ambitious climate goals. AADV5 builds that evolution right in. It future-proofs the buildings, keeps them pushing the envelope on efficiency.
That makes sense, keeping things moving forward. So what specific things need to be monitored according to this standard? It sounds like more than just one main meter.
Oh, definitely. It's about getting a really comprehensive picture. First, you have to monitor whole building energy consumption for each energy source. Think of it like a detailed household budget, but for the building. You track electricity separately, natural gas separately, district energy like steam or chilled water separately.
So you know exactly where the usage is coming from. Precisely. If your gas usage spikes unexpectedly, you know to look at the heating system first, not randomly search everywhere. That disaggregation is key for targeted savings. Second, you need to monitor building peak electrical demand, recorded at least monthly. Peak demand that's the highest rate of electricity use during a billing cycle, often in like a 15 or 30-minute window, right?
That's the one. And it's super important because utilities often charge a lot based on that peak, not just total consumption. It's called a demand charge.
Right, I've heard those can be a huge part of the bill.
They absolutely can. So understanding and reducing your peak demand, huge cost savings. Plus, it helps the grid less need for expensive, often dirty peaker power plants. Knowing your peak helps with strategies like shifting loads to off-peak times or participating in demand response programs.
Okay, so whole building use by source and peak demand. What else? The third piece is tracking on-site renewable electricity generation. So if you've got solar panels on the roof or maybe small wind turbines, that needs to be metered too.
So it's the net picture, what you use minus what you make.
Exactly. It gives you that holistic view, how much you draw from the grid versus how much clean energy you produce yourself. It shows the building's true environmental impact and its contribution. It's the full energy story.
And these requirements, they apply pretty broadly, don't they? Even for renovations or projects with exceptions.
Yeah, that's a key point. Even under special conditions, like major renovations affecting only part of a building or projects that might get certain ASHRE exceptions, the core rule still stands. Install measurement devices to track the whole building's energy use and its peak demand monthly.
So the principle of data-driven management is basically non-negotiable for LED certification now.
Pretty much. It shows how fundamental they consider this step towards smarter energy use, regardless of the project type. It's foundational.
Got it. That flexibility while keeping the core requirement makes sense. Okay, so that covers the monitoring part, the what and how of collecting the data. But the second criterion is reporting energy data. Just measuring isn't enough, you have to share it. What does that commitment involve? Right, and this is where the long-term accountability really kicks in. Project teams must commit to providing annual reports to the U.S. Green Building Council, USGBC. This isn't just a one-time thing to get the certificate.
An ongoing commitment.
Yes, exactly. It's recurring. And that's crucial for verifying that the building keeps performing well long after the ribbon cutting. The USGBC collects this data, which helps maintain the integrity of the whole AIDS system. It makes LEED a partnership for ongoing sustainability. And these reports need to include monthly energy data for a full consecutive 12-month period. The consecutive 12-month part is important.
Why is that?
Because it captures the full annual cycle, you see the winter heating peaks, the summer cooling loads. It accounts for seasonality. This allows for real, meaningful year-over-year comparisons. You can track progress, spot trends, benchmark against other buildings accurately. It gives you a robust data set for analysis. And the specific things you report, they directly mirror the monitoring requirements. So you report total energy consumption by each energy source, your on-site renewable energy generation, and your peak electrical demand.
So what you measure is exactly what you report, creates a clear link.
Precisely. It's a closed loop, designed for accuracy, transparency, and verifying performance over time. No ambiguity, just clear accountability.
Makes sense. A very logical structure. Now, you mentioned this is an ongoing commitment.
Yeah.
How long does this annual reporting have to continue? That seems like a pretty significant dedication.
It is significant. The reporting has to go on for at least 5 years after the building gets certified, or alternatively, until the building changes ownership or lessee.
5 years minimum. Wow. Yeah, it's a serious commitment. And it's critical for tracking that long-term performance. It ensures the efficiency designed into the building actually sticks around. It prevents that scenario where a building looks great for certification day, but then performance slips because maybe things aren't maintained or operated optimally.
Right. Avoids the set it and forget it problem.
Exactly. It emphasizes a life cycle approach. The building remains accountable.
Now, you mentioned an exception, though, for core and shell projects. How does that work? Yes, there's a practical exception there. Core and shell projects where the developer builds the main structure, the envelope, the core systems. But tenants fit out their own spaces later. They may exclude energy services and meters that tenants will install in their own spaces.
Okay, so the developer isn't responsible for metering the tenant's specific lighting or equipment inside their leased area.
Correct. It wouldn't be practical or really fair for the developer to monitor energy use within spaces they don't control after leasing them out. Tenants install their own stuff, lights, computers, maybe even specific HVAC units sometimes. So that raises a question. How does that flexibility work without weakening the overall requirement? Does it still ensure fairness and applicability? It's a really important balance. By allowing this exclusion, LEED acknowledges the reality of different development models. The requirement applies where the developer has control, but it doesn't completely ignore tenant energy use. Often, things like green lease agreements or tenant fit-out guidelines encourage tenants to install their own efficient systems and maybe even do their own monitoring.
So it pushes responsibility to the right place.
Exactly. It keeps the prerequisite strong but practical. It ensures accountability where it can actually be managed, making it achievable across different project types without creating impossible hurdles. It's a smart compromise, really.
Yeah, that sounds very pragmatic. Okay, so we've covered the what and the why of EAP4 pretty thoroughly. But like you said, it's not just about meeting the minimums. It's about getting the most value out of this. So what are the best practices? How do teams really knock this out of the park and maximize the benefits?
Great question. The absolute first and probably most impactful best practices integrate metering systems early in design phases to optimize cost and performance.
Get it in from the start. Don't wait.
Exactly. Trying to retrofit meters later, it's
Yeah.
often way more expensive. You're drilling through concrete, running wires in finished spaces. It's disruptive, costly, and you might not even be able to put the meters in the optimal spots for good data. Plan it during design. You can place sensors perfectly, integrate them smoothly with the building's infrastructure, especially the building management system, the BMS. It avoids headaches, saves money long-term, and ensures you get high-quality data from day one. Metering becomes part of the building's intelligence, not an add-on. Then, think carefully about the meters themselves. You need to select advanced energy meters with data logging and easy integration into building management systems, BMS, or cloud platforms.
So not just a basic spinning dial meter.
Definitely not. We're talking meters that can log data frequently, hourly, 15-minute intervals, maybe even faster. They need storage. And crucially, they need to talk to other systems easily. Integration with the BMS is huge.
Why the BMS specifically?
Because the BMS is the building's brain. It controls HVAC, lighting, other systems. If your energy data feeds directly into the BMS, you can correlate energy use with things like temperature, occupancy. The system can even make automated adjustments based on real-time energy data.
Intelligent control loops.
Exactly. And cloud platforms add another layer, remote access, powerful analytics using AI, secure long-term storage. The key is user-friendly tech that makes the data accessible and genuinely useful, not locked away in some complex system.
Makes total sense. Make the tech work for you. Now, you mentioned frequency. The prerequisite says monthly, but best practice is monthly or more frequent.
Yeah.
Why go more frequent? What's the real gain? Well, think about it. Getting a single energy number once a month versus seeing how much you used every hour or every 15 minutes, it's a world of difference for diagnostics.
Right. You can spot problems almost immediately.
Exactly. That weird overnight spike, you see it the next morning, not a month later when the bill arrives. Maybe a pump is running when it shouldn't be. You can intervene fast. That granularity lets you fine-tune operations much better, respond quicker, and ultimately save more energy and money faster. It turns data collection into active, real-time management.
Couldn't agree more. But all this great tech, all this granular data, it doesn't help much without the people and processes, right?
Absolutely critical point.
You have to establish clear roles and responsibilities for regular data collection, reporting, and analysis. Someone needs to own this.
Otherwise, the data just sits there.
Or gets mismanaged, yeah. You need to clearly assign tasks. Who checks the meters are working? Who downloads the data? Who validates it? Who generates the USGBC reports? And maybe most importantly, who actually analyzes the data to find those savings opportunities?
Could be facilities managers, energy analysts.
Could be, or IT folks, sustainability coordinators. Depends on the organization.
Huh.
But without clear ownership and defined workflows, the system's potential just won't be realized. It's the human expertise that turns raw numbers into strategic action.
That human element is key. Which brings us to the ultimate goal, really. Taking all this measuring and reporting and actually using it. Yes, the ultimate goal is definitely to leverage collected data for ongoing energy audits, identifying efficiency opportunities and operational savings. It's about that continuous improvement mindset, not just compliance. And this is where it gets really powerful. The data becomes this active management tool. Instead of a big, infrequent energy audit giving you a snapshot from maybe months ago.
You have a perpetual audit.
Exactly. You're constantly monitoring trends, spotting deviations from your baseline, seeing where consumption is creeping up. It lets you find problems quickly, a sticky valve, a leaky pipe, lights left on, and fix them fast. Or plan strategic upgrades, knowing exactly where they'll have the biggest bang for the buck. So maximizing impact means turning energy management from this periodic chore into a dynamic, real-time optimization process. That's how you get the big environmental and financial wins over the long haul, making the building truly smart.
That's the vision. And look, for listeners who want to dig deeper into this or maybe implement it themselves, there are some fantastic resources out there. Think of these as your essential toolkit.
Okay, good. What should people look for?
First, definitely the LEED V5 credit library on the USGBC website. That's the official source. All the specific requirements for EAP4 documentation needs, official interpretations, it's all there.
The definitive guide.
Absolutely. Then, of course, ASHRAE Standard 90.1 itself. You need to understand the technical details of how systems should be designed, installed, and metered according to that standard. It's fundamental. Then there's a really practical tool, Energy Star Portfolio Manager. It's a free online platform from the EPA.
Yeah, I know Portfolio Manager. Lots of buildings use that for tracking and benchmarking.
Exactly. It lets you track energy, water, emissions over time, and crucially, compare your building's performance to similar buildings nationwide. That context is invaluable for setting goals and seeing where you stand. You can visualize data, set targets, even get Energy Star certified.
Very useful. Anything else?
One more I'd mention is the DOE Building Energy Metering Best Practices Guide. That's from the Department of Energy. It gives really practical, hands-on advice on setting up and using metering systems effectively. Goes beyond just compliance into real optimization strategies. So connecting these back to the big picture, these aren't just documents, they're the guideposts for mastering energy performance. They give you the frameworks, the tools, the practical advice to go from theory to real impactful action. They empower those data-driven decisions for more sustainable, cost-effective, resilient buildings.
Excellent resources. Okay, that brings us towards the end of our deep dive for today. Hopefully, you're all feeling much more informed now, maybe even a bit inspired by what data can do for sustainable buildings. And remember, that core message, it really sums it all up. Measure accurately, report transparently, manage sustainably. And based on everything we've discussed, here's a thought to take with you. If we see widespread adoption of this kind of detailed energy monitoring and reporting, how might that change things beyond just individual buildings? Could it actually help create more resilient, more efficient energy grids for whole communities, maybe even cities? Imagine every building feeding intelligent data into the larger system. What could we unlock in terms of grid planning, demand response, maybe even how we distribute sustainable energy? What really stands out to you about the power of data in making things more sustainable? That's our deep dive for today. We really hope you found it valuable. If you want to keep exploring these kinds of topics with us, definitely make sure you subscribe to hear more about this world. You won't miss our next deep dive into whatever fascinating subject we tackle next.